Hi there! Welcome to this tutorial. Today we're going to learn how to build a real-time human pose detection system using YOLOv8. Don't worry if you're new to this. I'll guide you through each step in a clear and straightforward way. Let's get started. Imagine a smart system that can instantly spot and track how a person moves just by looking at a photo or video. That's exactly what we've built using the latest YOLOv8 model. This project brings real-time human pose detection to life, whether you're working on security footage, fitness tracking, or game development. We train the model using the COCO dataset, a large, diverse collection of human poses. Once trained, the model can detect body movements in both photos and live videos. But it's not just about predictions. The output is easy to view, share, and even customize. You can tweak the model's settings, change the data, or adjust the visuals to suit your needs. Whether you're analyzing a still image or a real-time video feed, this project makes pose detection fast, smooth, and user-friendly. Now, imagine you're just browsing online, curious about how pose detection works using AI. You type something like real-time human pose detection AI online course into Google. One of the top results will take you to this page. Aionlinecourse.com, real-time human pose detection with YOLOv8. On this page, you'll find a full breakdown of the project, including how the YOLOv8 model is used for detecting human poses. There's a coding playground where you can test it live, an interactive Gradio demo, and detailed explanations of how keypoints and bounding boxes work in real time. It's a hands-on, beginner-friendly space to learn, test, and experiment, all right in your browser. Implementation steps at a glance. First up is data collection. Collecting labeled human poses from the COCO dataset, a go-to for pose estimation. Next, we prepare the images, resize them to a uniform size, and clean them up a bit. This helps the model learn better and generalize across different types of images. We use the YOLOv8 model. It's fast and built for real-time object detection like this. After that, we move on to training. We train the model on our dataset and use a validation set to adjust and avoid overfitting. Once training is done, we perform evaluation. We test it on new data to check how well it can detect poses. We use something called MAP, a popular accuracy score. Finally, we display the results with bounding boxes and run live pose detection using a tool called Gradio. Now, let's move on the coding section. Mount Google Drive. We first import the Drive module from Google Colab. This lets us connect Colab with Google Drive. Next, we mount Google Drive to the Colab notebook at the folder path content drive. That's it. Now we can read and save files directly from Google Drive. Install and check Ultralytics. We start by installing the Ultralytics package. This gives us access to the latest YOLO models. Next, we import the Ultralytics module into our notebook. Finally, we run ultralytics.checks to make sure everything is installed correctly and the system is ready. Awesome! Now YOLO is set up and ready to go. Import the required libraries. We start by importing the YOLO model from Ultralytics. This line helps us display images directly in the notebook. PIL is used for opening and editing images in Python. This brings in the main Ultralytics module. NumberPy lets us handle image data as arrays, super helpful for processing. We use OpenCV's imred to load images from our system. Finally, we bring in matplotlib for plotting images and reading them too. Great! All tools are now loaded, and we're ready to work with images. Build and train the pose model. Here we build a brand new YOLOv8 pose model from its YAML configuration. Next, we load a ready-made, pre-trained model. This is the quickest way to start training. Or combine both. Build the architecture from YAML, then pull in the pre-trained weights for a head start. Finally, we train the model on the COCO pose sample set for 10 epochs with 640 pixel images. Awesome! your pose model is now training and learning to spot human joints. Check Training Results folder. This command lists all the files and folders inside the Training Results directory. It helps us see the outputs, like logs and saved models from our training. Great! Now we can explore the training results and evaluate the model. Visualize the confusion matrix. This code loads and displays the confusion matrix image from your training results. It shows how well the model predicted keypoints. More diagonal hits mean better accuracy. Now, we can visually judge how accurate our model really is. View the training progress graph. This line shows a graph of the training process. It includes metrics like loss, precision, and recall. It helps us understand how well the model learned over each epoch. This image typically includes graphs that summarize training performance over time. You will see the training summary graph from YOLOv8. It's a quick visual check to see how well your model trained. Look for loss going down and map going up. See pose predictions on training images. First, we import the image class from ipython.display. This allows us to show images directly inside Jupyter Notebook or Google Colab cells. Now, let's display the image. This image is likely generated during pose estimation training. The image shows a batch of training images with pose estimations drawn on top. These are usually skeletons or stick figures showing human joints like elbows, shoulders, and knees. This is useful for debugging and checking if your training data is being loaded and annotated correctly by the model. Running this line will display a training sample from your pose estimation model, helping you visually inspect the model's performance on a batch. Load and validate our trained pose model. This line loads the best performing model we trained earlier. Now we validate the model using the same data. It checks how well the model performs. These lines print out evaluation scores, like mean, average, precision at different levels. The higher the score, the better your model is at detecting poses. With validation complete, we now know how accurate our model really is. Visualizing the validation labels. First, we import the image class from the ipython.display module. This allows us to show image files directly in a notebook like Google Colab or Jupyter. Now we're going to display a labeled validation image used in a pose estimation model. This image is automatically generated during validation and contains the ground truth labels, meaning the actual human-labeled keypoints and pose skeletons for that batch. We're setting the width of the image display to 600 pixels, so it appears clearly in the output. The height is scaled automatically to keep the shape of the image correct. This is a visual representation of the correct pose labels in your validation data. In the image, you will likely see human body keypoints, colored skeleton lines, connecting joints, possibly bounding boxes around people. These labels are what the model is trying to learn to predict. Showing them helps you confirm that your dataset is being read and used correctly. After running this line, you'll see the ground truth labels for the first batch of your validation data. It's a good way to double-check that your annotations are working as expected. Load your trained YOLOv8 pose model. In this line, we're loading our trained YOLOv8 model from Google Drive. This is the .point file we saved after training. It's now ready for testing or real-time detection. Model loaded. Time to put it to work. Test the model on an image. We're running our model on a single .jpg image. The show conf equals false hides the confidence scores, and save equals true saves the output with pose detection on the image. Now that inference is complete and the annotated video has been saved, We display the final output directly in the notebook so we can visually inspect T. Show the pose detected image. This part loads the pose detected image and displays it clearly without axis lines, nice and clean. That's it. You're now seeing the result of your human pose detection in action. The image likely shows the output of a human pose detection model, probably with humans detected, and their key points connected by lines to form a skeleton. You might see circles or dots on shoulders, elbows, knees, etc. Lines connecting joints to form stick figure skeletons, possibly confidence scores or labels to visually verify that YOLOv8 model has correctly detected human poses and mark them on the image. Great for reviewing model performance frame by frame. Load your trained pose model. This line loads your custom-trained YOLOv8 pose model from Google Drive. It's ready to detect human poses using your best weights. Perfect! Our YOLOv8 N pose detection model is now loaded with the best trained weights. We're all set to start making predictions. Run pose detection on a video. This command runs pose detection on a video file. It reads the video, applies your model, and saves the result with poses drawn. We turn off the confidence display using show CONF equals false. Pose detection complete. Your output video is now saved with keypoints drawn. Compress and display your output video. We define a helper called showVideo that takes the path to our raw video. Build a new file name and path for the compressed copy. Run ffmpeg to re-encode the video with H.264, smaller but still clear. Read the compressed file, convert it to a base64 data URL, and hand it back so we can embed and play it inside the notebook. Watch your final output, pose detection in action. We give the path to our final pose detected video. The show video function compresses and prepares it for display. This part embeds the video player directly in your notebook, so you can click and watch your results in action. That's it. You've just visualized real-time pose detection using YOLOv8 right inside your Collab notebook. That's it. You've just built a real-time human pose detection system using YOLOv8. Here's a quick recap of what you've accomplished. Learned how pose detection works, used a powerful model like YOLOv8 run real-time detection on videos, created a live demo interface using Gradio. Whether you're planning to build a fitness app, a gesture tracker, or just exploring computer vision, this is a solid project to add to your portfolio. Now it's your turn. Can you tweak the YOLOv8 model to detect multiple people in a busy video frame and test how accurately it tracks their poses in real time? Try it out using the live playground on the project page here. Aionlinecourse.com. Real-time human pose detection with YOLOv8. Bonus task. Change the input source to a webcam or a video file and see how the model performs. If you're excited to build more AI projects like this, don't forget to visit Aionlinecourse.com and subscribe to the channel for more hands-on tutorials and AI content.